Microsoft is claiming a major leap in quantum computing. The Majorana 1 chip, faster, smaller, and more powerful than anything you have ever imagined.
In 1977, NASA launched a message in a bottle into the void. That was the Voyager 1 probe. It carried Beethoven, Chuck Berry, and greetings in 55 languages. And for nearly 5 decades, it drifted silently. Until now. Because, according to Elon Musk, something in that silence just whispered back. And no, this isn't sci-fi clickbait. This is the story of how a 47-year-old spacecraft, a quantum chip, and the world's most controversial billionaire might be rewriting everything we thought we knew about cosmic silence. Let's dive in. The shock claim. This piece of science involves a real quantum breakthrough called Majorana 1, a chip so sensitive it can detect quantum patterns that traditional computers literally can't see. Microsoft says it's the future of error-free quantum computing. But what does Musk say about all these? Well, he has expressed his concerns, saying that it's already decoding signals hidden deep in Voyager's old data logs, signals we missed. And if that's true, we're not just talking about a tech upgrade, we're talking about the possibility that something out there tried to talk to us, and we might have been too dumb or slow to hear it until now. In a recent conversation with Lex Fridman, Elon Musk did what he does best. He cracked open a philosophical can of worms and let it spill all over the cosmic carpet. Sitting across from the soft-spoken MIT researcher, Musk wasn't talking rockets or Twitter drama for once. He was staring down the future of the human species, and what he said was equal parts sobering and spine-tingling. I suspect that if we are able to go out there and explore other star systems, Musk said, there's a good chance we find a whole bunch of long-dead one-planet civilizations that never made it past their home planet. Let that marinate for a second. Not ancient aliens in UFOs, not galactic empires, but planetary tombstones. Graveyards of entire civilizations that never quite made the leap. Maybe they got wiped out by war, environmental collapse, or sheer cosmic bad luck. Maybe they built pyramids, smartphones, and particle colliders and vanished before anyone could notice. It's a chilling thought, and it changes the tone of our entire spacefaring story. Because if Musk is right, and let's be honest, even when he's wrong, he's still close enough to make headlines, then this moment we're living through isn't just exciting, it's urgent. If civilizations can rise and fall without ever touching another star, what makes us think we're immune? And this is where the Voyager 1 probe enters the chat, like a dusty postcard from a younger, more idealistic version of ourselves. Launched in 1977, long before Elon Musk was tweeting about Martian colonies or building flamethrowers, Voyager 1 was humanity's message in a bottle. It carries the famous Golden Record, a 12-inch, gold-plated copper disc etched with music, greetings in 55 languages, images of Earth, and even the sound of a kiss, a weird little time capsule meant to whisper, "Hello, we existed," into the void. At the time, it was a kind of poetic long shot. No one really expected aliens to intercept it, but it wasn't really for them. It was for us, a symbolic moment of cosmic optimism, of looking outward. Fast forward nearly 50 years. Voyager 1 is still out there, still alive technically. It crossed into interstellar space in August 2012, becoming the most distant human-made object in history. It's now over 15 billion miles away from Earth. And while its instruments are aging, its data is still trickling back. Radio pulses beamed across a chasm of darkness. But here's where things get wild. The Majorana 1, a quantum chip developed by Microsoft, isn't just another computer upgrade. It's built using topological qubits, an ultra-stable form of quantum information that resists the chaos and fragility plaguing other quantum systems. Theoretically, it's one of the first chips capable of fault-tolerant quantum computing. Translation? It can detect patterns where traditional computers just see static. Now imagine pointing that kind of processing power not at a modern dataset, but at Voyager's dusty old telemetry, its long-forgotten radio logs, its magnetic field data, its audio transmissions from deep space. According to speculation fueled by none other than Musk himself, Majorana 1 might already be doing exactly that, digging through Voyager's backlog and picking up things we missed. Hints, patterns, whispers, maybe even a signal that's been sitting there for decades, buried beneath our technological incompetence. A message, not necessarily in English or binary, but in quantum structure, in fluctuations, in harmonics, something that didn't make sense until we had the right kind of mind or machine to interpret it. And if that's the case, then we may have already been contacted. Not yesterday, not in the next decade, but back in 1980, or 85, or some random year when Voyager's antennas tilted just right. But because we were too early, too primitive, too analog, we never saw it until now. Think about what that means. Think about the timing. At the very moment quantum computing begins to flex its muscles, and at the exact same time, artificial intelligence is rewriting the rules of communication, we return to the data we thought was silent, and find out it might have been singing all along. Of course, this is still speculation. Musk hasn't confirmed anything definitive. Microsoft is staying tight-lipped about what Majorana 1 has actually unearthed, but you can feel the tension, the what-if. Because if we decode anything in that old data, anything that doesn't look like cosmic background noise, then everything changes. Suddenly, the golden record isn't just a hopeful gesture, it's a handshake, and that haunting silence of space, well, it might just have been a waiting room. So here we are, standing on the edge of a 47-year-old signal, armed with a quantum chip and a curious mind, trying to answer a question older than civilization itself. Are we alone? Or have we just been too slow to listen? To decode this mystery, we need to rewind 15 billion miles and decades of silence and hit play. The backstory: Voyager 1 and Majorana 1. 1977. NASA straps a nuclear battery to a gold-plated record player and fires it into the void. No trial run, no do-overs, just hope. That was Voyager 1. On September the 5th that year, our gold-plated record player was sent to study the outer solar system and the interstellar space beyond the Sun's heliosphere. It explored the Jovian and Saturnian systems, discovering new moons, active volcanoes, and a wealth of data about the outer solar system. In August 2012, Voyager 1 entered interstellar space, becoming the most distant human-made object in existence. That was Voyager 1, a cosmic postcard. And for 47 years, it's been drifting further, past Jupiter's storms, Saturn's rings, out past Pluto, beyond the heliosphere, into the interstellar void. No signals, no signs, just silence. Until now. Because, according to Elon Musk, that silence wasn't empty, it was hiding something. And to understand why that's terrifying and thrilling, we need to rewind. Here's the thing about deep space. It's loud. Cosmic radiation, solar winds, pulsars blasting like interstellar foghorns. Our classical computers filter all that out as noise. But what if buried in that noise, there was a pattern? A whisper we couldn't hear? That's where Voyager's golden record comes in, because it wasn't just music and greetings. It was a Rosetta Stone for aliens, a primer on how to decode us. And if we sent instructions, what if something sent them back? We built the golden record to talk, but what if we forgot to listen? Because here's the kicker: space isn't silent. It's a screaming quantum static, and Voyager's been swimming in it for decades. The golden record was a bet, a gamble that if aliens found Voyager, they'd crack it open like a cosmic vinyl and go, "Oh, humans, quaint." But after decades of transmission, Voyager's signals degraded. Static, silence, or so we thought. Because here's the kicker: silence isn't always empty. In quantum physics, empty space isn't nothing. It's a seething quantum foam, particles flickering in and out of existence. And if Voyager's data was drowning in that noise, well, that's where Majorana 1 comes in. Meet the Majorana 1. Microsoft's groundbreaking quantum processor powered by topological qubits. Utilizing a new class of materials called topoconductors, Majorana 1 achieves topological superconductivity, enabling the creation and control of Majorana particles. These particles, with their non-abelian braiding statistics, form the basis of a more stable and error-resistant form of quantum computing. In other words, a Majorana fermion is a particle that's its own antiparticle. No, really, it's like finding a shadow, which is the object. These things don't just exist. They braid through space-time, leaving error-resistant quantum trails. Microsoft's breakthrough. They tamed these ghost particles, wired them into a chip that doesn't just compute, it listens. Like a quantum detective, picking up whispers in a hurricane. Microsoft's Majorana 1 chip uses them to do what classical computers can't, decode signals buried in quantum noise. The unique properties of Majorana fermions allow for detecting subtle patterns in data that classical computers might miss. This capability opens the door to re-examining Voyager 1's transmissions with fresh eyes, or rather with a new kind of computational lens. Think of it like this. If Voyager's data was a scratched-up vinyl, Majorana 1 isn't just playing it. It's rebuilding the song from the grooves we thought were dust. Microsoft didn't just build a quantum chip, they built a time machine. Their top conductor design traps Majorana fermions in nanowires, letting them braid quantum states without collapsing. That means error-free decoding. And if Musk is right, we might have missed Voyager's whispers, because classical computers literally couldn't see them. For 47 years, we thought Voyager's data was just cosmic small talk. But what if it was a distress call, a warning, or worse, a hello we were too primitive to hear? Now, imagine applying Majorana 1's capabilities to the decades-old data from Voyager 1. Could there be messages or patterns hidden within that we were previously unable to detect? The possibility is tantalizing. As we stand at the intersection of past exploration and future technology, the convergence of Voyager 1's journey and Majorana 1's computational power invites us to reconsider what we know and might yet discover. The whispers from the edge of our solar system may still have stories to tell, waiting for us to listen with new ears. So here's the real question. What if Voyager wasn't just talking to itself? What if there was a reply in all that static, a signal so quantum encrypted, so alien, that we needed a quantum Rosetta Stone to crack it? Elon's hinting at it. Microsoft's chip might be proving it. And if that's true, then the real message from Voyager isn't in the golden record. It's in the silence we never understood. Until now. So, what do you think it said? The discovery. Alien message? It started with a vibration, not a sound. It's not a radio wave. A quantum tremor buried so deep in Voyager's data logs that it took a ghost-hunting computer to find it. Microsoft's Majorana 1 chip didn't just scan the noise. It listened sideways, peeling back layers of cosmic static until it found a pulse, a repeating resonance at 1420 05751 MHz, the exact frequency at which hydrogen atoms hum in deep space, the universe's natural radio station. And that's where things get weird, because this wasn't random static, it was structured. A pattern of blips spaced 1.1 seconds apart, with fractal-like echoes that almost looked mathematical. Elon Musk called it the first whisper from the void. But here's the kicker. We've heard this song before. Let's rewind. A Voyager 1 launched in 1977, right? Golden record, Beethoven. Greetings from Earth in 55 languages. A time capsule hurtling into the black, carrying a handshake across the stars. And for nearly 50 years, it drifted through space, dutifully pinging home with telemetry data. That's fancy English for spacecraft health checks, position logs, temperature readings, all the boring stuff. Except, lately, it hasn't been so boring. In 2022, NASA engineers started noticing something off. Voyager was sending back information, but it didn't make sense. According to every official schematic, data was being routed through a system that should have been dead decades ago. The signal was clean, no distortion, but the source of that signal? A total mystery. Engineers were scratching their heads. Why was an ancient subsystem, long dormant, suddenly back online? And more importantly, what else might be piggybacking on that transmission? That's when things got even weirder. Fast forward to early 2025. Musk, being Musk, had been quietly funding experimental uses of Microsoft's Majorana 1 chip. a next-gen quantum processor powered by something called topological qubits. Long story short, these aren't your average qubits. They're built from Majorana fermions, elusive, ghost-like particles that are their own antiparticles. The result? Near-perfect stability and error-free quantum calculations. This means this chip isn't just fast. It's accurate enough to notice patterns inside patterns that a normal computer wouldn't even recognize as data. So Musk gets his hands on raw Voyager logs. The public domain is freely available, but mostly ignored. He throws them at Majorana 1 and lets the chip run wild. No constraints, no filters, just cold, raw quantum processing. And then something surfaced. According to insiders at SpaceX's Red Team Labs, the chip flagged a repeating resonance inside a specific telemetry packet from 2022. A structure, not noise, not random, something patterned, and not once, but over 17 separate data batches spanning months. A recurring waveform that only appeared when data was routed through that mysterious, supposedly dead subsystem. Let me be crystal clear. This isn't a, we found alien lyrics encoded in gamma rays moment. Nobody's hearing Morse code from Alpha Centauri. But this is the first time a quantum chip has flagged something in our data that we didn't program, didn't expect, and couldn't detect until now. And the emotional part about this is that this could be a techno-signature, not proof of life, not a little green voicemail, but a statistical anomaly in a pattern that has no known terrestrial explanation. And for people like Musk, who believe the universe should be teeming with intelligent life, that's enough to start shaking the table. So, what exactly did Majorana 1 find? That's where it gets murky. Think binary pulses, but irregular. Think fractal patterns, but layered. The chip picked up quantum harmonics that echoed like brainwave interference, almost like electrical patterns in neural circuits, but they were coming from deep space signals. The repeating blip occurred at 1420 MHz, a hydrogen line, the universal hello in radio astronomy. Coincidence? Maybe. Or maybe something, or someone, was using hydrogen's universal frequency to tag a message, a call, a marker. You might think, okay, but isn't this just like the WOW signal back in 1977? Good instinct. The WOW signal was a narrow-band radio burst picked up by Ohio State's Big Ear telescope. It lasted 72 seconds and was never repeated. One big, what the hell was that? Moment in SETI history. We still don't know what caused it. Then there was BLC-1, Breakthrough Listen's 2020 claim to fame. A narrow signal near 982 MHz was detected in the direction of Proxima Centauri. It looked alien. It sounded alien. It triggered every protocol for an interesting signal. Until it didn't. It turned out it was Earth-based interference. But the way it was handled, that changed SETI forever. Because even though BLC-1 was a false alarm, the methodology it introduced, checking for Doppler shifts, equipment crosstalk, and repeatability, gave us a framework, a scientific language to separate anomalies from fantasies, and Majorana 1 is rewriting that language again. Unlike BLC-1 or WOW, this isn't about a telescope signal from space, it's about telemetry, spacecraft data from us that somehow contains patterns we never put there, and maybe couldn't have. Here's the million-dollar speculation. What if Voyager passed through something during its endless drift through interstellar space? A field? A stream? A transmission? What if that dormant subsystem, suddenly back online, wasn't reactivated by chance, but by contact? Now, hang on, because this is where the story takes a deep philosophical breath. Imagine sending a message across the cosmos, only for it to bounce back, years later, hidden in the guts of your machine. A message you weren't even smart enough to notice the first time. That's the scale we're talking about here. A cosmic delay so long, so nuanced, it requires quantum computing to even recognize. And the moment we did, the moment we finally got smart enough, boom, there it is. A ripple in the noise. And here's Musk, standing over a chip that just might have caught the whisper of a civilization older than ours, smarter than ours, or long gone. And he's not saying, it's aliens. He's asking, why didn't we hear this sooner? But of course, not everyone's buying in. NASA's engineers are still investigating Voyager's funky data reroutes. Officially, they call it unexpected but not necessarily anomalous behavior, which is bureaucratic speak for "we don't know, but we're not saying aliens." The mainstream response has been measured. SETI researchers want peer review, replication, and confirmation before whispering the A word. But that's the thing with thresholds. We never know we've crossed one until we're already standing on the other side. And with Majorana 1, we might have just done that. Because now, we're not just asking, are we alone? We're asking, did we miss the message the first time? Did we brush past a signal from the stars like a radio dial skipping over the one station that mattered? And if so, what else have we missed? Here's what we know. Voyager 1 is still out there. The data still trickles in. Majorana 1 is still decoding. And Musk, he's just getting started. He's already hinted at open sourcing the flagged dataset, letting the quantum nerds, conspiracy theorists, and AI codebreakers have at it. One big global sandbox for our generation's greatest what if. So maybe, just maybe, the message was always there. We just weren't ready to hear it. The speculation, real or hoax? Let's get one thing straight. Elon Musk didn't just say something weird. He basically tossed a Molotov cocktail into the SETI community and walked away, grinning. In his now infamous Lex Fridman interview, Musk didn't mince words. Humans are bad listeners. We miss things. We always have. And when he says bad listeners, he doesn't mean missing your friend's birthday text. He's talking about Voyager 1, about the data we've had for decades, about messages we might have already received and flat out ignored. And what's worse, he says we missed it, not because it was too faint or cryptic, but because we didn't have the tools to hear it properly. That's where Majorana 1 enters the chat, the new AI-driven chip that, according to Musk, is finding quantum fingerprints buried inside Voyager's transmissions, not glitches, not background fuzz, fingerprints, like something or someone pressed back. Now, before we jump off the deep end, let's hit pause. Because for every Elon-level mic drop, there's a room full of scientists who've spent their lives chasing signals from the stars, and they're not all ready to scream aliens just yet. Let's enter the SETI researchers. These are the pros, the people who've been scanning the sky since before Elon had a Twitter account, and even they're a little shaken. One researcher pointed out that if the Majorana 1 chip really is pulling quantum-level anomalies from old analog signals, we may be on the brink of decoding what traditional computation could never pass. That's not a small statement. That's like saying your dog suddenly started reading War and Peace in Russian. The interest isn't just because it's new tech, it's because this chip relies on Majorana fermions, exotic quantum particles that can encode information in ways normal binary logic can't. Microsoft even said this tech could unlock error-free quantum computing, and now Musk's team is using it to tear apart Voyager's old data logs, bit by bit, qubit by qubit. So yeah, there are believers. People are genuinely excited that we might finally be hearing the other side of a cosmic voicemail we've been ignoring for 47 years. But then, there are the skeptics, the ones with scars from false alarms. Remember BLC-1, that infamous signal from Proxima Centauri that had the internet lighting up like it was Independence Day? SETI teams heard a narrow-band transmission that looked alien. For weeks, people were running wild with it. This is it, they said. We finally made contact. But then it all unraveled. Fast. The source? A human-made signal that just looked extraterrestrial because of a mechanical hiccup and some wishful thinking. It's a cosmic prank played by our own faulty equipment. Astronomers haven't forgotten that burn. That's why when Musk starts talking about quantum chips decoding something weird from an ancient probe, their first instinct is to squint and say, define weird. Some experts already point out that space probes like Voyager aren't immune to signal corruption. Cosmic rays, temperature changes, and even the simple degradation of analog tape can inject noise that looks like a pattern. One Nature researcher cautioned that without multiple independent verifications, even the most dazzling signal can be a mirage. Instruments lie, she said. The cosmos doesn't, and it's not just the skeptics throwing shade. SETI's cautionary policy, particularly from METI, Messaging Extraterrestrial Intelligence, urges us to remember that listening is not receiving. They warn about confirmation bias. about seeing patterns because we want to, not because they're actually there. They call for patience, rigorous replication, and, above all, humility. But Musk doesn't really do humility. That's part of why this story hits so hard. Deep down, this isn't just a debate about data. It's about who gets to declare the future. Is it the old guard, the radio astronomers with their mountains of skepticism and white-knuckle control over methodology? Or is it the iconoclast, the guy who sent a Tesla to Mars and now claims he's hearing alien echoes in an old probe's static? And here's where it gets even wilder. The chip in question, Majorana 1, isn't just some theoretical toy. It's built to catch non-classical patterns. This means that if there was a signal laced with quantum encoding, this would be the first moment in human history we'd actually be able to catch it. Let that settle in. What if there was a message encoded in quantum entanglement? Something deliberately hidden because the senders knew we weren't ready until now? But even if that's true, and that's a galaxy-sized if, we have to remember BLC1. We have to remember the false starts, the headlines that turned into retractions, the moments that felt like first contact until they didn't. So, where does that leave us? On one side, we have Elon Musk, a man with a track record of overpromising, yes, but also someone who's reshaped entire industries. He's not always right, but he's never boring. And when he says we might have missed a cosmic hello, people listen, even if it's through gritted teeth. On the other side, we have the scientific establishment waving the caution flag, reminding us that extraordinary claims require extraordinary evidence, that if this is real, it needs replication, documentation, peer review, and a lot more than a spicy podcast quote. And yet, in the middle of that tension, that's where the magic is. Because maybe this isn't about proving aliens tomorrow. Maybe it's about finally having the tech to ask better questions, to dig into old signals with new tools, to wonder what else we've missed while staring at the sky with the wrong ears. So, is this our Rosetta Stone, the cracked code that rewrites human history? Or is it just another cosmic red herring? Something strange but ultimately meaningless, buried in the hum of a 20th century machine? Why don't you give us your take in the comment sections? Think about this. Voyager 1 wasn't supposed to talk back. It was a message in a bottle, our hello to the cosmos. But if something answered, that changes everything, because suddenly we're not the lonely kids shouting into the void. We're part of a conversation we didn't even know was happening. And what if we've been missing the replies all along? The implications, if it's real. In the cold black of interstellar space, Voyager 1 isn't just a drifting antique. It's a voice, still speaking, still sending data across 15 billion miles like a ghost with perfect memory. 47 years and counting, and we're still listening. But here's the real kicker. What if we were never actually hearing it right? Because that's the heart of this twist. It's not just about some chip picking up static. It's about the idea that humanity's most iconic deep space emissary might have been transmitting something this entire time, and we just didn't have the ears to catch it. Imagine designing a time capsule for alien civilizations, only to realize the real message wasn't the golden record at all. It was buried in the quantum noise, encoded in math, and meant for something or someone smarter than us. But with Microsoft's flashy new topological chip, we're no longer deaf to the cosmos. This isn't just a quantum chip. It's a universal translator, born out of quantum chaos and stabilized by exotic particles called Majorana fermions. This thing doesn't crash under pressure like our classical computers. It surfs the uncertainty. Think of it like the first translator that doesn't just read the alien script, it feels the intention behind it. This means that we're listening sideways, decoding patterns classical computers dismissed as noise. And here's where Elon loses his mind. Apparently, XAI ran Voyager's old data through Majorana 1, and the output? It's not random static, no background noise, patterns, repeating, structured, rhythmic, in a way that classical code just wouldn't pick up. Now, could it be a software glitch? Sure, but that's not the vibe coming from inside the valley. There's a different kind of tension right now. It is one that feels less like a programming error and more like a translation delay. Like we just opened an envelope from the stars and we're staring at the letter, trying to understand if it's a love poem or a warning. And this This is what Musk's whole Mars obsession suddenly pivots around. Because now, the multiplanetary survival pitch doesn't sound so sci-fi. If someone, or something, did try to reach us, and we didn't hear it for 47 years, what else have we missed? What else are we missing? SpaceX isn't just about colonizing Mars, it's about building an off-Earth insurance policy. And XAI? That's not just a vanity project. It might be the only tool capable of parsing the nuance in cosmic syntax. Because what if the universe doesn't shout? What if it whispers? And we, noisy, distracted, tangled up in our own mess, just never learned how to listen. Here's the existential gut punch. Maybe the question isn't whether we are alone. Maybe it's whether we are ever capable of hearing the answer. And now, with this chip, with this breakthrough, we might be closer than ever. But here's the real terror. What if we weren't supposed to hear it yet? 47 years ago, we launched a golden record into the dark, a love letter to the cosmos, a hello with no guarantee of reply. Now, Voyager 1 might have answered, not with words but with patterns that only Majorana 1 could hear. This isn't just about technology, this is about legacy. So, was that signal just cosmic noise, a glitch in the quantum matrix? Or, and really think about this, was it the universe testing us, seeing if we'd evolve enough to listen? Elon's right about one thing: we are bad listeners. We filter out what we don't understand. We dismiss what scares us. But Majorana 1, it doesn't filter, it hears everything. So now the real question isn't, did something talk to us? It's, what happens when we talk back? Sound off in the comments below. Do you think we just overheard the universe's secrets, or are we finally on the guest list? Either way, the conversation's just getting started. Don't forget to like and subscribe.